Hello everyone, I am Sachin and this is the part 2 of training about what is Guardium and how does it work. Please take a moment to go through this disclaimer. This is the agenda for the training. The grey colored topics are already covered in part 1 and in this part 2 I will cover demonstrations on life cycle of a packet. Before we jump into the demonstration of life cycle of a packet, let me quickly revisit this diagrammatic representation from part 1. A traffic packet contains the connection profile from the DB client to DB server. A client sends a request to the database server. The server processes and responds with the requested data. STAP, a lightweight agent installed on the operating system where the database is installed. It copies the traffic between the client and the server, sends this copied data to the Guardium appliance for analysis. Sniffer on Guardium collector receives the copied data from the STAP. It analyzes, parses, and logs relevant information into Guardium's internal database. Now let's move on to the demo that shows local traffic and remote traffic to explain life cycle of a traffic packet. For this demo, I am going to use predefined reports that are shipped with the product in order to display the data and explain life cycle of packet. So this is the official documentation for predefined reports. There are three categories: admin, user, and common reports. We have logged in to our collector appliance. The first report is sessions list. If the report isn't added in any of the reporting groups, then user interface search does not show it. From query report builder, we will search for sessions list report and add it to my custom reports. Once you find the report, click on it. Open original if you are not going to make a copy and edit that report, and add to my custom reports. The default lookback period is 3 hours, so this report is already displaying some sessions. The next report is DDL commands. We will add it to my custom reports in the same manner. Go into the query report builder, search for DDL commands, click on the report. If you are not going to clone and modify it, click on open original and then add to my custom reports. The third report that we are going to look into is full SQL report. We are going to add it in the same manner. Search, open original and add to my custom report. Now let's execute some traffic on the DB. This is my Oracle database on a Red Hat Enterprise Linux system. I am using SQL Plus to log in. Let's check how does it show up in the sessions list report. Since the default lookback period is 3 hours, let me narrow it down to the last 5 minutes. So this is how the Oracle session is displayed. The source program is SQL Plus. Look at the DB user. And since the client IP and server IP are the same, the network protocol is coming as Beckwith, which is a local traffic. No session end is recorded here, so let's log out of this session. Disconnected. Let's go back in the sessions list report. It might take a second or two for the session end to get recorded. Let's execute some remote traffic using this dbeaver tool. Let me connect to the database. Okay, so these are the list of few commands that we are going to execute. The login from this dbeaver utility has opened 3 sessions as per this report. Look at the source program. The network protocol is TCP because the client IP and server IP are different, which means a remote traffic. Let's execute some DDL command. So let's create this table employees, execute, and let's run another DDL for altering the same table. Done. To view this SQL activity, let's open the DDL commands report. So this report shows client IP, server type, and the SQL verb. So we executed create and alter. So the SQL verbs here are coming in as alter table and create table. Now let's execute some more SQL activity, and this time after the DDL commands report, we'll use the full SQL report as well. So we have inserted a record, we have updated a record, and let's delete a record. Since this is just a test setup, I'm dropping the table as well. Let's see what more DDLs we have, and yeah, there is the drop table DDL recorded too. Seeing the full SQL report here now, let's change the look back period to 5 minutes so that we will see the most recent activity. We can sort this interactive report using the timestamp column and arrange it in descending order to see our activity. Let's scroll through the report. As you can see here, the source program of dbeaver and that create statement that we had executed. Then we have the alter. As we scroll further, we have witnessed this insert activity too, the update. Then there are other pages as well. So let's move on to the next page and we see this delete command and the drop table as well. Going back to the sessions list report, and the sessions are still active. Let's go and disconnect it from here. Refreshing the report and we can see the session ends recorded. Now in this report, the timestamp column is from the collector system, while the session start and session end are from the DB server. The entity and reports awareness session will enlighten us more about the timestamps. Let's move on to another demonstration for life cycle of a packet. So an enterprise mostly uses applications for connecting to the DB. I have created this Python based app to generate some traffic for Oracle and DB2 database. and we have this collector system ready and logged in. Let's see if we have any entries in the sessions list report. Let's start with the DB2 database. We have opened the session and let's see how does that connection profile look like for DB2. There you go. Now let's close that DB2 session. Session closed. As we have witnessed earlier, it takes a second or two for the session end to come and populate here. Now let's do the same thing with the Oracle DB session. As you can see, the session was opened and a non-existing table was queried. That's how it looks like. And let's see the Oracle connection here in the sessions list report. You can see the source program as Python 3, and let's close that session, refresh the sessions list report and see if the Oracle session end gets recorded. There you go. Let's check the full SQL report and see what are the activities conducted behind the scenes by that particular application traffic. So you see the source program as Python 3 here. You see the service name, database name, DB username, client IP and server IP columns. You get to validate everything here, and these are the SQL statements. Those were run into the background. Taking you back to the sessions list report, here you can see session and column value empty. If by any chance the session remains open for a prolonged time, we do have a mechanism called session inference that scans for inactive session and marks it as inactive after a set threshold. So polling interval and maximum inactive period. Polling interval refers to the time after which the session inference feature checks for inactive session. And maximum inactive period refers to the idle time of the session that inference will check before marking it as inactive here. So that was all I wanted to cover in today's session for this part 2. Hope this was informative from a fundamental knowledge standpoint. So let's revise the life of a packet. This was how the traffic packet started from the DB client, moved to the DB server, the STAP captured that traffic, moved to the collector, and from the collector it was generated into reports.